Hello and welcome to this week's research vlog. So I'm going to go over some stuff that I covered a while ago, but it's ramping up to this kind of effect. And so what this is this is the Verneuil pieces building from their neighbor, and they don't just scale up, they actually translate. If you look closely, they translate from their neighbor. And so I'm going to show how to do this effect here. So in this video I'm going to be talking about the constraint network. Now I've upgraded my Verneuil fracture here, and I think I talk about this in another video, to have the create prim ID attribute on there. And what that does is that goes through and that gives for every primitive it has a unique identifier to it. And that goes through this Connect Adjacent Verneuil here. And so this is like Connect Adjacent Pieces, but it's a little bit faster. And maybe there's a better way to do this, but this is how I'm doing it. So this is what we get. We get a network right here. And so what it does is, I'll walk you through it. It takes the input and it has the primitive ID on it. That's very important as the primitive attribute. And it has the text name and some other attributes I may or may not use. And so here's a trick that I came across in other OTLs to basically get the centroid, and that's an attribute of the Verneuil pieces, and that's very important. So what we can do is we can just keep the inside, and the way this works is the inside of Verneuil are identical faces pretty much. It's the same kind of face. And so what we can do is we can facet them, make them unique, promote that primitive ID. These attributes are getting promoted to the point, because what we have to do is we got to delete the geometry and then we connect it up, so into one primitive. And then what I do is I scale it down to 0, every primitive. And then I carve it down, and what this carve does is it basically gives me a point per primitive. And then just with some fusing, so you have two identical faces, and then you crush them down to a point, and then you fuse those points, and then you go back to the original faces, and then you just basically do this near point here. You find it nearest. So whatever these points, whatever the nearest fuse is right here, the merged points, we set that as an attribute. And then what we can do is we can add create polygons based on the nearest, because those two individual points will share a point. And then what we do is we just move it back, the position of those points, to the centroid of the centerpiece, and you have a network that inherits from inherits the primitive attributes from the points. And I'm pretty sure you could boost up the Connect Adjacent, but I like doing it this way but this only works with strict Verneuil pieces. So this was a way I do it. That's pretty handy. So probably next week I'll go over the effect that allows you to grow the pieces. It's rather in depth, so it's a lot of this stuff. So I'll go over that the next couple weeks. Alright, thank you for watching. I hope you enjoyed learning, and happy Houdiniing. Have a great week.